Hello, good afternoon to all of you. Today I'm going to discuss some general questions in probability. Already I have discussed probability for cards and balls. Now I'm going to general questions of probability. Let us see the first question. Already I have told what is meant by probability and where we are going to use the probability. Now let us see directly to the first question. How to solve the questions I'm going to explain to you. Let us go to the first question. The first question says A and B go for interview for two vacancies. The probability for selection of A is 1 by 3 and the probability of selection of B is 1 by 5. What is the probability that none of them is selected? Now there are some cases where a wife and a husband go for an interview. The chance of selection for a husband to get the job is 1 out of 3. That is a male member, and the chance of selecting of the wife is 1 by 5. That is a female member. That means out of 3 posts, there is one chance for A. 1 by 3 in the sense out of 3 vacancies, there is one chance for A to get selected. For the sake of B, out of 5 vacancies in girls or ladies, there is one chance of B to get selected. Now let us read the question. A and B go for an interview for 2 vacancies because A can take only 1 vacancy. In the same way, B can take only 1 vacancy. The probability of selection is 1 by 3 for A and the probability of selection of B is 1 by 5. Now we need to find out the probability that none of them is selected. Now let us see for the solution. A to get selected is probability 1 by 3. That means out of 3 chances there is one chance for A to get selected. For A not getting selected, so if total probability is 1, 1 by 3 is the probability of getting selected. So the probability of not getting selected is 1 minus 1 by 3. That is nothing but 2 by 3. This is for A. So the probability of getting selected for A is 1 by 3. The probability of not getting selected for A is 1 minus 1 by 3. That is 2 by 3. 1 is a total probability. 1 by 3 is a probability of selection of A. We need the probability of non-selection of A. That is 1 minus 1 by 3. That is 2 by 3. In the same way, let us take for B. The probability of selection of B is 5. Out of 5 vacancies, there is one chance for B. The probability of not getting selected is 1 minus 1 by 5. 1 is a total probability. 1 by 5 is the probability of selection. We need the probability of non-selection. That is nothing but 4 by 5. Now, the question says, what is the probability that none of them is selected? So, A getting not selected is 1 by 3 is getting selected. 2 by 3. A not getting selected is 2 by 3. B not getting selected is 4 by 5. The probability that none of them is selected is a question. That is 2 by 3 for A not getting selected. 4 by 5 for B not getting selected. If you just calculate, that is 8 by 15. So out of 15 vacancies, if you think there is 8 vacancies where they are not getting selected. That is the first question. Is it clear? A and B go for an interview for 2 vacancies. The probability for selection of A is 1 by 3 and the probability of selection of B is 1 by 5. So the probability that A is not selected is 1 minus 1 by 3, that is 2 by 3. The probability that B is not selected is 1 minus 1 by 5, that is 4 by 5. So the probability that both are not selected, none of them is selected is 2 by 3 into 4 by 5, that is nothing but 8 out of 15. Let us go to the second question. 100 students appeared for 2 different exams. 100 students appeared for 2 exams. 60 students passed in the first exam. So the second 50 students passed in the second exam and 30 passed in both different I'll repeat the question. 100 students appeared for an examination. We can go for the Venn diagram type of questions or we can deal it in a different type of probability method also. 60 passed in first exam, keep it aside. 50 passed in second exam, keep it aside. So now in first exam, if we take 60 passed in the science, 40 failed in the first exam, 50 passed in the second exam in the science, 50 failed in the second exam, 30 passed in both the exams in the science, in both the exams together, 70 failed. Now let us go to the question. Find the probability that a student selected at random, left, if you take any student suddenly selected at random, he failed in both the examinations. So a student selected in random must fail in both the exams. What is the probability for finding that the student selected at random failed in both? Now let us go the questions in clarity. So totally 100 students appeared for an examination. In one subject, 60 passed. 60 passed in the first exam. That means 100 out of 100, 60 passed in first exam. In the same way, 30 passed in both exams. You can see the next line. Second person, if you give it aside, 60 passed in first exam, 30 passed in both exams. So 60 minus 30 in the sense 30 passed in only one subject. That is what it means. Let us take the second case. 50 passed in second, 30 passed in both. So 50 passed in second exam, 30 passed commonly in both exams. So 50 minus 30 gives 20. That is 20 passed in second exam. Now the question is, what is the probability that a student selected at random failed in both the examinations? A student selected in random failed in both the examinations. Now 30 are the persons who passed in one exam, 20 are the persons who passed in one examination. Okay, and 30 are the students who passed in both. There are three cases. 30 passed in first exam, 20 passed in second exam, 30 passed in both exams. Now the question is, what is the probability that a student selected random failed in both? So total 30 plus 20, 50, 50 plus 30, 80 students passed in both exams. So 100, if you take 100 minus 80, 20 are the students who failed in both the exams. So again I'm telling the question, 60 passed in first exam, 30 passed in both. So step number 1, 60 minus 30 means 30 passed in first exam. In the same way, 50 passed in second exam, 30 passed in both. So 50 minus 30, 20 passed only in the second exam. 30 commonly passed in both the exams. So total number of students who passed is 30 in the first, 20 in the second, 30 in both. Total it is 80. So 100 minus 80 gives 20 failed in both the examination. If you go for the probability here, 20 out of 100, that is nothing but 1 by 5 is the answer. The probability that a student selected in random failed in both the exams is 1 by 5. Let's go to the next question. Question number 3. A pair of 8 slided dice have sides 1 to 8. Now coming to dice, we know that there are 6 sides in the dice. For the sake of questions, there are 8 sided dice. Now let me draw the shape. For example, 8 sided in the sense, you can take it as like this. Here comes 1. This is 1. This is 1. So one more I'm drawing for you. This is 1. Okay. So 1, 2, 3 and 4. Down also we have the same 1, 2, 3 and 4. I'm not able to show it properly because it's a two-dimensional. I will draw an open dice for you. So let us take this. If we take a dice, let us give some numbers. 1, 4, 2, 6, 8, 3, 7, and 5. So this is nothing but a dice which is having 8-sided. This is one end. This is one more. This is one more. That means dice I have opened it for the sake of you to understand properly. If you take an 8-sided dice, so a pair of 8-sided dice, 1 to 8, have sides 1 to 8 and the numbers are also 1 to 8. Each side has some probability of landing face up. So if you just throw a die like this, you'll get one face at the top. The probability of two numbers, the question, the probability of two numbers on the side that lands face up exceeds 36. The probability of two numbers on the side that lands face up. So now I'm going to see one face. So here suppose 1 is there. And one more face if I put, suppose it is 7 is there or 4 is there too. Like this, if we take two faces or two numbers, that means the dice I'm putting 2 times, it must exceed 36. Now total there are 8 sides. In 8 sides, total combinations out of 8, first I'll get one chance. That means one face will come off out of 8. And second time again I'm repeating it. Out of 8 again I'll get one face on the top. One face out of 8. With some number say 4. One face out of the 8 faces with some number say 6. So 8 into 8 is 64 combinations are possible for us now. Let us take 64 chances are there. Now the question says what is the probability of two numbers that face up exceeds 36. Now let us see how can you get 36? Let us see. I am writing here the place is little less. Say for example, you can take 5 and 8. That is nothing but 40. Okay, 6 and 7, 42. 6 and 8, 48. 7 and 6, 42. 7, 7, 49. 7 and 8, 56. 8 and 5, 40. 8 and 6, 48. 8 and 7, 56. 8 and 8, 64. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I am getting 10 sides where the sum or the product is that which is exceeding 36. Now let us see. So there are 10 possible chances to get numbers which exceed 36, and coming to the denominator as it is 64. So that is you can cancel it with say 2. 2 5 is 10, 2 3 is 6, 2 2 is 5 by 32 will be our answer. Now I think it's clear. So what generally we do is we take a general die which has 6 sides. So the numbers will be 1 to 6. Here I am taking for the sake of question a dice which has 8 sides. In that 8 sides there will be 8 numbers. In this 8 numbers we'll get any number if we put a dice. And second time when you're going to do the same thing, we are going to get one more number. What is this then? The two sides which just take the product, it must exceed 36. Here we have the some cases where we are getting more than 36. If I take some other number like 4. 4 into 4 is 16, or 4 and 6, 4 and 8 is 32. One die is 4, one die is 8, it is 32. So answer is 5 by 32. Let us go to the next question please. Question number 4. A total of 15 dots are there. In that 15 dots, if you select 3 dots randomly, what is the probability that 3 dots make a triangle? So my students will get it out. Now I am going to take 15 dots. Shall I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I take some 15 dots, there is no order for the dots. Now I am going to select 3 dots randomly. Any 3 we can select. So what is the possibility that 3 dots make a triangle? If you have a 3 dots which are non-collinear, which is not in the straight line, definitely we'll get a triangle. So we need 3 non-collinear points where we're going to get a triangle. If we take these 3 dots which are not in order, I can make a triangle for this. So if you just join those 3 dots, I may get a triangle. I can join these 2, I can join like this, so like this. The question says, so automatically there are 15 dots. In this 15 we need definitely 3 dots to make a triangle. So 15 C3 is 15 into 14 into 13 by 1 into 2 into 3. That gives rise to, for example, 2 sevens are 14, 3 fives are 15. That is 35 into 13. That is 455. So the denominator is 15C3. Coming to the numerator, what is the probability that the 3 dots make a triangle? So number of dots required to make a triangle. Okay, so total number of dots not to get a triangle, if we take it, is 15. Total number of dots not to get a triangle, okay, it's 15. So 455 minus 15 is equal to 440. That will be the numerator. So 455 is the denominator, 440 is the numerator. If you are going to solve it, you may get the solution for this. That is, you can simplify the same thing. So 440 by 455. You can cancel it with, say, 5. 5 8s are 40. 5 8s are 40. 5 9s are 45. 88 by 91 or so. Let's go to the next one. Seven Indians, 4 Americans and 2 Germans are to be selected or to be seated on 13 chairs for a photograph. So first of all, I have given 4 options for you. Let us see. There are 7 Indians, 4 Americans, 2 Germans. So total 7 plus 4, 11. 11 plus 2 is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 13 spaces are there. 13 chairs, say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 chairs are there for us. So out of these 30 chairs, what he is going to tell is they are going to sit for a photograph. Who are going to sit is 7 Indians are there, 4 Americans are there, 2 Germans are there. If a photograph is clicked, what is the probability that in the photo no 2 Indians are together? So 1 Indian, 1 Indian, 1 Indian, 1 Indian, 1 Indian. Total we have how many Indians? If we take 7, 1, 2, 3, 4, 5, 6 and 7. No 2 Indians must sit together. So Indian can sit only in alternately. They cannot sit together. They cannot sit together. The question is, if a photograph is clear, what is the probability that no 2 Indians are together? Now let us take Indians are 7. I am writing for the sake of understanding. Let us mix 4 Americans and 2 Germans. So 4 Americans and 2 Germans, 6 members, can sit together. There is no objection here. Only Indians cannot sit. So 4 into 6, say American plus German. These are all one unit, and 7 Indians are another unit. So 6 Americans plus Germans are 1 unit, 7 Indians are 1 unit. So automatically German and American can sit together. Only Indians cannot sit. So Indians will definitely sit alternately. Now starting second, let me take say American or German. 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 German. 1, 2, 3, 4, 5, and 6. So 6 are the persons where I have circled are either Americans or Germans. Remaining are Indians. 1, 2, 3, 4, 5, 6, 7. So 7 Indians and 6 American bar Germans. Total there are 13. So answer will be definitely 7 factorial B option into 6 factorial, 7 for Indians, 6 for Americans plus Germans, by 13 for total. B is definitely the right answer. If we take the first option, 7 factorial can be Indians, 4 factorial can be Americans, 2 or Germans, but they can sit together. So first option is not correct. Second option can be taken. Third option, if you take only 7, he has given only for Indian. Out of 13 factorial, he has left the German. Because it's a photograph, even the Germans and Americans must sit. Last one is 7 factorial by 1, 2, 3 is not the right option. Now, it is ridiculous, option D. So, second option is the right answer. Let me go to the next question. 3 humans are available in a locality. Sorry, I'm very sorry. 3 houses are available for 3 houses. House 1, house 2, house 3. 1, 2, 3. 3 houses are available in a locality. 3 persons apply for the houses. That means one person want to take a rent, second person rent, third person they want to come for rent. Apply in the sense they're not applying for any job here, they're going for rent into that house without consulting others. 3 are the different persons. Suppose how they will consult each other? They cannot consult because they are the different persons. So 3 persons without consulting each other, they have applied for 3 houses in one locality. Okay, the question, what is the probability that all the 3 apply for the same house? So first person, if I take, in general I am telling, out of 3 houses he can go for 1. So 1 out of 3. Second person will go for 1. 1 out of 3. Third person will go for 1. It is also 1 out of 3. So first person 1 out of 3. Second person 1 out of 3. Third person 1 out of 3. So 3 chances. For first person there are 3 chances apply. Second person there are 3 chances. That means any of the 3 houses he can select. There is no guarantee that he'll go only for the first house. There is no guarantee that he'll go only for the second house. He can go for any house. So first person there is 3 chances. Second person there are 3 chances. Third person there are 3. Totally there are 27 chances for the 3 persons. Now the question is, all the 3 apply for the same house. So it is 1 by 27 into 3. All the 3 persons are applying for the same house. That is totally the 27 chances. Means 1 by 27, 1 into 3 are applying for the same. That is 1 by 9. So the answer is 1 by 9 ways. What is the probability that the 3 will apply for the same house is 1 by 9. I think it is clear for you. Let me go to the next one. Question number 7. Say, there are 5 green balls, 7 red balls. 2 balls are to be selected 1 by 1 without replacement. Here let us see. There are 5 green balls. G1, G2, G3, G4, G5. There are 5 green balls and 7 red balls. Red 1, red 2, red 3, red 4, red 5, red 6, red 7. 2 balls are selected 1 by 1 without replacement. 2 balls are selected 1 by 1 without replacement. That means once I have taken the ball, it will not be placed again into the same bag or whatever. So that means if you want to replace, suppose there are 5 green balls and 7 red balls, with replacement in the sense, once if I take one ball out, again I have to replace it. Here it's not like that. 2 balls are selected without replacing. That means you need not replace it again. Find the probability that first is a green one and the second is a red one. Is a simple question. So there are 1, 2, 3, 4, 5, 5 green balls. P of gain, probability of selecting the green and probability of selecting the red. Now, as you know, there are totally 5 plus 7, 12. Okay. So there are 12 balls. In that 1, 2, 3, 4, 4. Out of these 5 green balls, I am going to take 1. So 5C1 I can take. That is nothing but 5. Sort of 12. Now without replacing, in the sense I need not put the ball again back. I will not have again 12 balls. I will only have 11. Why? Because one ball I have taken out. In this 11 balls, I have to take 1, 2, 3, 4, 5, 6, 7 red balls are there. In 7 red balls, I can take any one. Only I have to select the red, not the green. In the first case, only I have to take the green, not the red. So out of the 5 green balls in the numerator, I can get 1, 5 out of 12 balls. In the second case, I am getting 7 by 11. That is, there are 7 red balls, but we have only 11 total number of balls. So the product gives the answer, that is nothing but 35. 785 by 12 into 11 is 132. Is it clear? If you have to, without replacement, if you want to replace it, for example, you have to select by replacing. If you get 5 by 12, again you will get 7 by 12 only. Why? Because you are going to replace the ball. So the number will not change. Let me go to the next question. A problem is given to 3 persons, P, Q and R, whose respective chance of solving it are 2 by 7. One problem is out of 7 chances. 7 times if we try, 2 times we will get success. 2 by 7 in the sense, so out of 7 times if we try the sum, 2 times there is chance for him to get or to solve the question. If we take the second case, 4 by 7, out of 7 chances, the second person can solve 4 times correctly. Out of the 9 chances, 4. So, a problem is given to 3 persons, P, Q and R, whose respective chance of solving it are 2 by 7, 4 by 7 and 4 by 9 respectively. The question says, what is the probability that the problem is solved? So, we need to get a probability that we are going to solve the problem. Let us see this. Probability that for selecting, that is the probability for solving the sum by P is nothing but 2 by 7 for P. Probability that he is not able to solve the sum is 1 minus 2 by 7. If 1 is the total probability, that is nothing but 5 by 7. Second case, that is Q. The probability of solving the sum is 4 out of 7. So the probability that he is not able to solve is 1 minus 4 by 7. That is, 1 is the total probability, 4 by 7 are the chances for him to solve. This is nothing but the probability of not able to solve, that is 7 minus 4, 3 by 7. For the same third person, if you take, his chances of solving the probability is nothing but 4 by 9. The probability for him to not solve the sum is 1 minus 4 by 9. That is nothing but 5 by 9. So what I am doing now, let us check. A problem is given to 3 persons, PQR, whose respective chance of solving it are 2 by 7, 4 by 7 and 4 by 9 respectively. What is the probability that the problem is solved? So for P, the probability of not able to solve the problem is 5 by 7. For the Q, that is the probability of not able to solve the problem is 1 minus 4 by 7, 3 by 7. For R, if we take, the probability of not solving of the question is 4 by 9. That is nothing but 1 minus 4 by 9. That is nothing but 5 by 9. So totally, the probability of problem getting solved is If the total probability is 1 minus the probability of not getting solved totally, if I remove the probability is a total 1 minus the probability as not able to solve the problem, if I am going to remove, I am going to get the solution that is nothing but 1 minus 5 by 7 into 3 by 7 into 5 by 9. I think you all know how to solve this. 1 minus 5 by 7 into 3 by 7 into 5 by 9. That gives nothing but 122 by 147. 122 by 147. You know how to solve the 3. That is 5 by 7 into 3 by 7. That's all is the solution. Let me go to the next question. A problem is given to 3 students. One problem is given to 3 students whose chances of solving it in the same type of previous question. One more question. A problem is given to 3 students whose chances of solving it are 1 by 2, 1 by 3 and 1 by 4. So for first person to solve the problem is half, 50%. The second person is 33.33, that is nothing but 1 by 3. The third person is 25%, 50%, 33% and 25%. What are the probability that the problem will be solved finally? So a problem is given to the 3 students whose chance of solving are like this. That is 1 by 2, 1 by 3 and 1 by 4 respectively. What is the probability that the problem will be solved? That is the question now. So the chances, let us see first, of the 3 persons not able to solve. For first person, 1 minus 1 by 2. 50% there is chance for him to solve, 50% is not able to solve. 33% the second person is able to solve, means 66.66% is not able to solve. That is nothing but 1 minus 1 by 3, that is 2 by 3. For the third person, the same case, 1 minus 1 by 4, that is 25% gone, means this is 3 by 4, 75%. So chances of the person able to solve, if you take chance of the persons not able to solve, if you take 1 by 2, 2 by 3 and 3 by 4, that is nothing but 1 by 2 into 2 by 3 into 3 by 4. If I take 3 cancel, 2 cancel, is nothing but 1 by 4. 1 by 4 in the sense 25%. Hence, the question says problem must be solved. For non-solving it is 25%. So the probability of solving the question is 1 minus 1 by 4 is nothing but 3 by 4. That is 75% there is chance for the problem to be solved. 75% there is chance of solving the question. Let's go to the next question. In a class there are 15 boys and 10 girls. Totally in a class there are 15 boys, 10 girls, means there is 10 plus 15, 25 students are there. 25 students in a class. 3 students are selected at random. 3 students we are going to select at random. The probability that 1 girl and 2 boys are selected. So in a class there are 15 boys and 10 girls. 3 students are to be selected at random. What is the probability that 1 girl is selected and 2 boys are selected? It's a probability question which is very easy. There are totally 15 plus 10, 25 students. So 25, how many are going to get selected? If you go for denominator directly, out of this 25, 3 are getting selected. So 25 C3. 25 C3 is nothing but 2300. That is 25 into 24 into 23 by 1 into 2 into 3. If I take, for example, 2 12s are 24, 3 4s are 12, 25 4s are 100 into 23, 2300. So 25C3, my dear students, is the denominator. Let's go to the numerator now. One girl must be selected. So how many girls are there here? There are 10 girls. In this 10, we have to take only one. In the same way, and how many boys are there? Two boys are to be selected. How many boys are there? Total 15. Out of this 15, we can take only two are to be selected. Total 1 plus 2, it is 3. So 10C1 is 10, 15C2 15 into 14 by 1 into 2, 2 sons of 14, that is 70 plus 35, 105. So numerator will be 1050. The final answer will be 1050. Numerator by 2300. Denominator you can make it into a short one by simplifying. 5 2s are 10, 5 1s are 5, 5 4s are 20, and 5 6s are 30. That's all, dear students. And if you want, you can cancel it. We cannot cancel it. So here what I'm going to do is, in a class we have taken, let me go to the next question now. So 10C1 again into 15C2 divided by 25C3. Let me go to the next question. Now we have completed. Let me recheck it. The 9th one and the 10th one. We are going for the 11th question. A basket contains, very important question. Let us check it. A basket contains 10 apples and 20 oranges. Out of which 3 apples and 5 oranges are defective. So in that basket there are 10 apples and 20 oranges, out of which 3 apples and 5 oranges are defective. If we choose 2 fruits at random, what is the probability that either both are oranges or in the sense, my dear students, is plus, both are non-defective? So we have two problems here. We have to select total how many fruits? 3 apples and 5 oranges are defective. How many have to select? 2 fruits only we have to select. At random, what is the probability that either both are oranges, one case, or both are non-defective? So let us write it as n of a, n of b, n of a union b, n of a intersection b also. We can write, for example, total if we take, there are 10 apples and 20 oranges, 30 fruits are there. In this 30 fruits, we are selecting only 2. Out of 30 fruits, we are selecting 2. That is the first case. Okay. Coming to the numerator, 2 must be oranges. 2 we are selecting. So oranges we have 20. Out of this 20, we have to select 2. So 20 oranges, we have to select 2. Total there are 30 fruits. This is 1. Now let us take the second case. N of a we can tell, or P of A probability, because P of B, if I take 30C2 is common. Out of 30 fruits, we are selecting 2. 22C2 will be the numerator. What is the 22C2? Out of the 30, 8 are defective. That is 3 apples, 5 oranges. So if I remove that 8, non-defective are 22. So 22 we have to select the 2. Both are non-defective. So 22C2 by 32. 30C2. Then P of A intersection B. What is this? Total 30C2 is common for us. 15C2 we are going to get. What is this 15C2? We are talking about both the oranges or both are non-defective. So out of 20 oranges, 5 oranges are not there because 5 are defective. Non-defective in the sense we have only 15C2 by 32C2. So totally if I solve, coming to the question, P of A union B is called P of A plus P of B minus P of A intersection B. That is nothing but I'll write here if you don't mind. 20C2 by 30C2 plus 22C2 by 30C2 minus 15C2 by 30C2. If I take that is equal directly, after solving at 316 by 435, that's all is answer, dear students. So 20C2 means 20 into 19 by 1 into 2, you know that type. Let me go to the next question. In a class, 30% of the students offered. In a class, 30% of the students offered English, in the sense they're going for English subject. 20% of the students offered Hindi. 10% of the students offered both. Now I can go for Venn diagram type. So probability for selecting English course, P of E. Suppose 30% are there, 30 out of 100. 30% are there, that is 30 by 100. 20% offer for Hindi, in the sense 20% of the students are going for Hindi. So in this sense, P of H, E means English, H means Hindi, that is 20 out of 100, 20%. You can take it as 1 by 5. English you can take it as 3 by 10. Next is 10% of the students offered both subjects, 10% are taking. That is P of E intersection H, both the subjects, 10%, 10 by 100, that's 1 by 10. Now let me continue. That is nothing but P of E union H is called P of E plus P of H minus P of E intersection H. That is nothing but 3 by 10 plus 1 by 5 minus 1 by 10. You know how to solve this. 3 by 10, 1 by 5 minus 1 by 10, that is nothing but 4 by 10 or 2 by 5. Let's go to the next one. A speaks truth in 75% cases. B speaks truth in 80% cases. In what percentage of cases are they likely to contradict each other, narrating the same incident? Now suppose A and B are there. A speaks truth in the sense B speaks false. That is called as contradiction. Now A speaks truth in 75% of the cases. That is nothing but, you can directly take P of A is called 75 by 100, that is equal to 3 by 4. Coming to the next, P of B, probability of B speaking truth is 80%, that is 80 by 100, that is 24 by 5. That is A speaking truth is 3 by 4, I'm sorry, B speaking truth is 4 by 5. Now let us take both contradict each other, in the sense, suppose A is speaking truth, I am writing here truth, B will speak false, or else A speaks false, B speaks truth. Let me check it. So A speaking truth, if I take one by 4. First is A speaking true, it is 3 by 4. B is speaking false, 1 by 5, because 4 by 5, 1 minus 4 by 5. In the same way, plus A speaking truth 3 by 4, B is speaking false. B is speaking truth is 4 by 5. 1 minus 4 by 5, 1 by 5 is B is speaking false. Coming to this, A speaking false is 1 by 4. B is speaking truth 4 by 5. If I solve this, what happens? Let me write here itself. That is 3 by 20 plus 4 by 20. That is 7 by 20. You can take it, my dear students. So question is, in what percentage is asking? Percentage is 7 by 20 into 100, 35%. 35% is the answer. Let me go to the next one. If two letters are taken at random from the word home, in home there are 4 alphabets. 2 alphabets are taken at random. What is the probability that none of the letters will be vowels? Now, my dear students, directly have written this because no place. If I take home, there is E1 vowel and O1 vowel. There are 2 vowels. Now, what is telling 2 letters are taken at random? Any 2 can take. So, out of the 4, 2 are taken. So, 2 by 4. That first letter is not vowel. That means out of the 4, 2 are vowels, 2 are not vowels. If I am taking 2 letters, the 2 may not be vowels in the first chance. So 2 by 4. The second letter may not be vowel. Already I have taken 1. There are only 3 letters now. In the 3 I am taking 1 where it may not be vowel. Now probability that none of the letters would be vowel. First chance 2 by 4, not vowel. Second chance 1 by 3, 1 by 6 are the chances of not getting the vowels. So what is the probability that none of the letters will be vowels is 1 by 6. What is the probability that we are going to get vowel means 1 minus 1 by 6, that is 5 by 6 will be the answer. Let me go to the next question. 15 people sit around a circular table. There is one circular table. Let me write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15 people are sitting same. What are the odds against 2 particular people sitting together? If I take suppose these 2, this is 1, this is 1, these 2 must be sit together. So out of 15, 2 are sitting together in the sense, 3 more or 13 more are remaining students. 15 people sit around a circular table. What are the odds against 2 particular people sitting together? So 15 people sit around a circular table in 14 factorial ways. First one person will sit, next the 14 persons will sit, because without fixing the first person, remaining cannot sit. So 14 factorial ways are there. For a required event to occur in which 2 persons sit together, 2 persons in the cells, 2 factorial ways. That means first person A, second person B, or there means A will sit first or B. There is no clarity. So 2 factorial ways, 2 persons can sit together, and the remaining are 13 students. So 13 factorial into 2 factorial has the required probability. If you go for directly, 13 factorial into 2 factorial will be the numerator by 14 factorial will be the denominator. It cannot be 15 factorial because one person must sit, again the 14 will sit. So 13 factorial into 2 factorial by 14 factorial. If you solve it, you are going to get 1 by 7. Okay, now coming to how many chances are, what are the odds against 2 particular people sitting together? So odds in favor are 1:6, 1 minus 1 by 7, 6 by 7, that is 1:6. Odds in favor of 1:6, odds against favor will be definitely 6:1. That's all for today. Thank you very much, dear students. Hope you understood my video. Thank you very much.